guest today for F+L Webcast is Uday Kumar. Uday is the Industrial Managing Director of PETRONAS Lubricants International. He is currently based in Kuala Lumpur at the PETRONAS Twin Towers. Good morning, Uday.
Good morning, Vicky. It's nice to be in conversation with you.
Thank you, and welcome to F+L Webcast. So Uday, let's start. Let's ask about yourself. You have a very rich background. You have a Bachelor of Engineering from Bangalore.
Yep.
And tell us your journey from engineering school to where you are now.
Thank you, Vicky. It's a long career, Vicky. I've been in the oil and gas industry. I started my career as a sales engineer after my mechanical engineering in Bangalore University. Then I did specialization in tribology as a special project post my graduation. But immediately after that, I joined Castrol India Limited, which is a part of BP Corporation as a sales engineer. Then I grew up in my career working in different parts of India, and then went on to head the business in India, then South Asia. Was also the sales director for Greater China. When I was based out of Shanghai, I managed the industrial lubricant business in Shanghai for 5 years. I came back to India in 2016. Then I was the global key account director for BP, managing the relationship with the Tata Group and BP. And then I did for a while business development work, including opportunities for BP to invest in new energy and EV charging network. And in 2020, post the COVID, I 22 actually, I joined PETRONAS Lubricants International. So it's been more than 3 decades of working in the lubricant industry. Most of my career has been in the industrial space. I fairly knowledgeable in all the markets in Asia. If you could say that, I kind of an expert, you can say, for industrial lubricants.
Yeah, Uday. So someone convinced you to go into tribology. Now, tribology is not a terminology that most people, ordinary people, understand, right? It's the study of friction and wear. It was a term that was coined, I think, back in the 60s. So who convinced you to get into this field?
Yeah, so I think I was always interested in friction and wear in my engineering days. So I happened to meet one Professor S.K. Biswas, who was a kind of a genius in tribology. He used to be a professor in Indian Institute of Science, one of the premier institutes in Bangalore. Talking to him, I got amazed of how lubrication plays an important role between friction and wear, and kind of the 3 dimensions of that business, of that science. That got me interested speaking to Professor S.K. Biswas, and that's how I got involved in some research work as a project assistant working for him for a while. And I published a paper on in the Tribology International along with Professor Biswas in research on studying of grinding media wear in ball mills.
And that got you hooked.
That got me hooked into lubrication. And then somebody came and told me that Castrol is looking for engineers to sell their lubricants. And I said, let me give a shot. And I went for the interview. And when I talked about my research in wear and tear, and they said, look, this is the exact profile we wanted you. Can you come and help us to sell your knowledge on tribology through the Castrol lubricants? And here I am after 30 years, still with the lubrication industry.
Congratulations. It's interesting. Being from the outside, what I've noticed is sales engineers usually have engineering backgrounds.
True.
Why is that?
So I think that's a very interesting question, Vicky, because most industrial machinery are always under maintenance and breakdown, and quite often these maintenance and breakdown happens because of various reasons. One of the important factors is inadequate lubrication or poor lubrication, or even sometimes improper lubrication. And an engineer could probably look at all these aspects and then suggest ways and means to improve lubrication, to improve productivity, reduce maintenance cost, reduce breakdown, and help uptime, increase uptime, and improve productivity. So lubrication plays an important role in industrial machinery maintenance, and an engineer understands this better than anybody else, because it's about understanding what the machinery are, and how lubrication plays an important role between these sliding and rolling surfaces in these machines.
Now, as a sales engineer, as a young sales engineer, who do you interact with? You go to the factory and talk to the maintenance people, or is there a tribologist in that plant that actually understands tribology, probably as well as someone who works for Castrol or Petronas?
Yeah, I think most companies do not have tribology as a department unless it's a significant, large size a steel plant where they do have lubrication departments, and in that lubrication department there could be some tribologists working. But all manufacturing companies do have a maintenance department, and the maintenance department, the job is to ensure the machines are up and running. They ensure that the maintenance of these machines are done through a scheduled maintenance, at times a breakdown maintenance, and so they understand machine in the way it needs to work, and what does the equipment manufacturer recommends in terms of the lubrication requirements, in frequency and the specification. And so when there is a problem in maintenance, they go to the manual of the OEM and check what does the OEM recommend in terms of the frequency of lubrication, or in terms of the specification of the lubrication. And then he looks for companies who can help and support him to get these specifications, or even suggestions, ways to improve the lubrication.
So industrial lubricants are a little bit different than automotive, right? So
Absolutely.
yeah, in industrial lubricants, it's really an OEM dominated specification. Like you mentioned, at the end of the day, you have $1 million machinery, you're going to look at the OEM manual and check what are the recommendations. But in the automotive space, although you also have OEM specs, you have industry standards that sometimes work with the OEM spec, or sometimes is in addition to.
Yeah.
So does that present a difficult challenge for suppliers like Castrol and Petronas? Because that means that you need to be OEM approved, right?
Absolutely. I think so. You're spot on, Vicky, because all equipments, when a designer designs an equipment, he would have had some design parameters incorporated when he makes those designs these equipments. And in those design parameters, lubrication and the specification of the lubrication are an important element when these machines are designed. So they do recommend the specifications and the grades of the lubricants to be used in during the maintenance of those equipments. Most equipment manufacturers insist that during the warranty period of the equipment, that the recommended lubricants to be only used if there is to ensure that the optimum productivity or optimum output of that equipment. post the warranty, it is left to the user to either use the recommended lubricants, which the OEM manufacturer recommends, or use lubricants which the maintenance manager is satisfied that it will do its job. So during the warranty period, it is mandatory that you need to necessarily use an OEM recommended products, or else the warranty will be null and void. So no user will take a chance to use lubricants which are not recommended by the OEM. And the OEMs also, what they do is they normally recommend brands of lubricants. So they test the lubricants for the physiochemical properties, the performance parameters in a test rig before they give a approval to the company and the brand and the specification which can be used on those equipments. I'll give you an example. A turbine which was a costly equipment, a capital intensive equipment, would need lubrication for its bearings. So the bearings obviously would be tested with different lubricants of different brands, and then the OEM would put in his manual the products which have been tested and approved by the OEM in his manual, so that the user can choose amongst the approved products when he commissions or when he is using those the turbine.
And a typical machine, how many years warranty does a manufacturer provide to the end user?
Commonly, most equipments are a 1 year warranty, but nowadays most equipments do have extended warranty going from 1 year to 5 years, and sometimes even up to 10 years. So it depends on the capital intensity of that equipment. But you can say on an average it is in a year, but most capital intensive equipments have 3 to 5 years.
Yeah, and obviously machines usually are what? They have a lifespan of maybe 10 to 20 years.
Yeah, it is for more than 10 years. It depends on also the usage of the equipment. There are some customers who would abuse that equipment to get its life as quickly, probably try to get the best of the equipment as early as possible, without probably maintaining the standards which required for maintenance. And so some last only just 3 years, but there are many who use it for 5 years plus and even 10 years. I'll give an example. A wind turbine lasts something like 25 years.
Wow.
A steam turbine in a coal power plant lasts, or a hydel power plant lasts 25 years.
But how frequent is their maintenance and their downtime?
So they are generally, there is a maintenance schedule for all these equipments. They are generally maintained on an annual basis. So they do take down annual maintenance schedules for these equipments to stop and look at all the wear and tear of that equipment, and then basis of that then decide on what needs to be replaced or what needs to be enhanced, or even change of lubricants whenever needed. So mostly equipments are on an annual maintenance schedule.
Uh, One of the trends, at least in automotive, is extended oil drain. Is that also a
Hmm.
trend in industrial lubricants?
Very much, very much. So as the technology of lubricants has been improving year by year, and also many of the lubricants have moving from mineral oil to synthetics. It also means that you are able to get better life of the oil, and so extended drain period intervals are normally uh, heard even in the industrial requirements, and in many industrial equipments you do condition-based monitoring. That is, you take samples on a regular basis and try to study the physiochemical properties of the product. And if the physiochemical properties of the lubricants are well within the specification, you are then able to extend the life of the lubricant. So it's important to ensure that you have a condition-based monitoring of the lubricants when there is a large lubricant requirement of in the machine.
Um, Uday, tell us condition monitoring. We've heard so much about it.
Mm.
Is this new? Is this an iteration of an old system? What were factories doing 30 years ago versus what condition monitoring is today? Has it
So I
changed?
Absolutely. It's changed significantly. And I think Industrial 4.0 is going to change further. So it's most machines. So let me start with what it used to be in the past. In the past, the equipments were probably of much slower speeds, and they were also the equipments were with the higher tolerances, and so the lubrication demand of the lubrication also was not very high in those days. Whereas the modern machineries are of higher speeds, higher productivity, and also with higher tolerances, lower tolerances, meaning they have very small sump size, less lubrication being used, and the output of these equipments are also much higher. So the demand of the lubrication is significantly higher. So obviously, to ensure the machines are up and running without any breakdown or without any loss of production, you need to have a continuous conditions-based monitoring. So today we do have online condition-based monitoring for some of those equipments, which are critical equipments, which are also on high demand in terms of productivity. So it's moved considerably, and Industrial 4.0 is all about connected machines, so that all the connected machines have sensors for various parameters of the equipment, be it speeds, temperature, vibration, and the likes, which are monitored on a continuous basis, and that can give you an indication how the machine performs. And through the data, big data, you will be able to do a predictive analysis of the equipment failure rate, and you can do preventive maintenance before a breakdown maintenance.
How prevalent is Industry 4.0 in Asia? Like, for example, let's talk about key markets like China and India.
It is gathering steam. It was predominantly more so in the Western world, where the labor costs were high, so there were less people to look after those machines, and that's why connected machines were part and parcel of any industrialization. In Asia, especially in India and China, the modern factories have now realized that condition-based monitoring and Industrial 4.0 can save them significant cost of these capital equipments, and also better uptime and productivity. So the modern factories are adopting Industrial 4.0, and I think the software industry is also helping them to get some of these dashboards on handheld devices to look at how the machinery operates.
Yeah, it would be easier though to start from scratch, right? A grassroots plant would be easier to make it
True.
a smart factory. But
Absolutely.
if you're talking about an old plant, for example, that retooling it would be a little bit tough, right?
Absolutely. You are right, Vicky. For a old plant to retool it is going to cost you significantly higher. Whereas when you start a new manufacturing plant, you can incorporate all these while you start designing the layout and the equipments, what needs to be in the manufacturing site. So you are right. It's much easier to adapt to these, straight away jump from nothing to the latest equipments, which are all wired up.
Now, do you also need a smart grid to get Industry 4.0 to work? Or, I mean, because the older grids are a little bit problematic, right?
Yeah, I think you are right. Definitely, because it needs internet connectivity, it needs continuous power. In many ways, you need to have all the elements what you would need in a modern smart manufacturing world. And I think we are seeing that in many countries in the Asian countries like Korea and Japan, smart manufacturing being part and parcel of the manufacturing process. Even in India and in China, the modern factories do have these elements now.
Now, in your current role, Uday, you're covering globally, right? You're not just, you're based in KL, but you're covering the entire world for Petronas
Absolutely.
Lubricants, which is, as the name says, international.
Absolutely.
Different levels of industrialization, different levels of modernity. So, what does a guy like you do to make you be able to sell more products? I mean, it seems like it's a lot of things on your plate.
Yes. So Petronas International Lubricants International has a global presence. We supply lubricants to our industrial customers in Latin America, in Europe and Middle East and Africa, and in Asia. So all the parts of the world. We have a significant presence in Brazil. We are one of the top lubricant companies amongst the international players. We have more than 16% market share in Brazil. So it's a huge manufacturing base, especially in agriculture. Brazil is one of the largest producers of uh, corn, soya, and maize, and they use lots of modern equipments in the agriculture industry. So we lubricate all these equipments with our customers there. Same is the case in Europe. We have a significant presence in Italy because Petronas Lubricants International heritage is Italian. So we started our operations through a subsidiary of Fiat before Petronas bought this company. So we have a big presence in Italy, and we are again one of the market leaders in the industrial space. So we have many of these equipment manufacturers who are using our lubricants and also recommend our lubricants when they export these equipments to all parts of the world. We do have a large presence in Malaysia because we are home based. We have a big presence here and have a growing presence in China and India, where we also have big teams in on the ground, helping and supporting our customers to improve their lubrication requirements, with also a manufacturing facility in China and in India. So one of the things which my job is to share best practices from different parts of the world to our customers, to get the best of the technology into these markets, be it from Europe to Asia, or the best practices from Asia to Europe or Latin America. So um, also, some of our global key accounts have manufacturing facility in different parts of the geography of the world, and we help them to get standardized lubrication for these equipments, get the same levels of service to ensure that the service requirements, what they are able to enjoy in one part of the world, is available to them in another part of the world where probably they would expect a supplier like Petronas to do the same standards.
Yeah, Uday, tell us about the industrial lubricants market. What is the current growth rate globally? And then what areas, what regions are the fastest growing?
So industrial lubricants is probably the largest space outside of the automotive lubricants business. Of course, the third business vertical is the marine lubricants. So the industrial lubricants large portion of the industrial lubricants is in automotive manufacturing, in mining, in agriculture, in construction and equipment, and in process manufacturing, be it chemicals and fertilizers and petrochemical industry. So all industries do have equipments, and when there is an equipment, there is a lubricant requirement to that. And so that's how the industrial lubricants is. So you have starting from hydraulic oils, gear oil, compressor fluids, greases, and then you also have automotive in the automotive manufacturing, metal cutting fluids, be it cutting oils, rust preventives, and the like forth. So all of them make good as industrial lubricants. Coming to your question on where is the largest industrial space, the lubricant requirement, more than 50% of the industrial lubricant requirement is in Asia, and it's growing rapidly because the industrial lubricant industrialization in India and China, and the two largest economies, are the biggest lubricant, the second and the third largest industrial lubricant market in the world. US, Germany, and Japan are being the other three in the top five. So the large growth rate is happening in China and India, and of course even in ASEAN as well, with Vietnam recently getting all the investments on the industrialization front. So um, Asia is the hub of most of the industrial activity, and industrial lubricants is growing at a much faster pace in this part of the world than in Americas or in Europe, Middle East, Africa.
Yeah, and it's interesting, Uday. So recently, the IMF
Yeah.
raised its economic outlook for Asia to 4.5%. How
Hmm.
closely does GDP growth follow or track industrial lubricant growth?
The industrial lubricant is around 1 to 1.5% growth rate globally. So that's the growth rate of the industrial lubricants. In Europe and in USA, the growth rate is probably less than 1%, whereas in this part of the world, it's around 1.5%. So on an average, the growth rate is between 1 to 1.5% industrial lubricant growth rate. So um, there is no thumb rule as such in terms of connected with the GDP growth rate, but um I believe it is uh, parallelly with the industrialization of those countries.
Will automation reduce lubricant consumption?
Absolutely. I think you are right. The more the automation, the less lubricant requirement, because the equipments will probably be needing specialized lubrication. So in terms of the value of the lubricant, there is a significant increase in the value of the lubricant, but in terms of the quantity of lubricants required, be much lesser. Uh, a robo manufacturing would need greases, specialized greases, so these are synthetic, high-performing greases, but manually manufacturing, say, a cement plant or a steel plant, which was of the old technology, would need larger lubricant quantity, but not necessarily higher performing lubricant requirement.
So, what are the most important trends in the industrial lubricant space? Circularity, is that one?
Definitely,
Biodegradability?
that's one of the things. And most companies now are emphasizing on ESG. So most of the boards are asking the organizations their commitment towards environment, to sustainability and governance. And so circularity is definitely one of the key areas for most industrial customers now. So less plastic being used, oil, they are looking at using oil which are recirculated or re-refined, and also having a lower carbon footprint. So energy saving. So in many ways, circularity, sustainability, and are part and parcel of the commitment towards the ESG, and the demand on suppliers to support them, to help them to these goals is important. So energy transition is another big topic now in many of the companies, going from the hydrocarbon energy related to new sustainable renewable power. In that regard, again, they are looking at wind energy and solar energy to power their plants. And again, lubricants also play an important role in wind energy requirements.
Yeah, in the industrial lubricant space, how do you reduce carbon footprint of your products?
So um, um, one, have to, the lubricant travels lesser. So in the past, there used to be large manufacturing sites, and from there it used to be exported around the world. Today we have locally sourced products and components which are locally manufactured, so that the products travel lesser to the customer site. So in many ways, you are able to reduce the carbon footprint of the product. So that's the first fundamental. The second is also to try to reduce the use of non-efficient ways of transport. So again, if you are able to use um, rail transport or ships to move these goods rather than road, which are much more efficient in terms of the carbon burning of fossil fuel. So these are different ways to reduce the carbon footprint of the products from an industrial requirement.
How big a carbon footprint does the last mile delivery have? Is it does it take up a lot of carbon footprint in your product slate?
So carbon footprint is something which we are trying to now map it at all levels, including the last mile. It does have an impact on the carbon footprint from a last mile perspective. So there are many ways to reduce that, trying to uh, supply in bulk instead of in smaller containers. We are also trying to see how can we have efficient ways of delivering products to our customers in terms of the delivery schedules, and also time of the days, so that we can reduce the carbon footprint in the last mile. I know in many industries they're using electric vehicles now for the last mile delivery in the automotive business. In the industrial requirement, we have yet to incorporate these electric delivery vehicles as yet, but I'm sure a day will come when the smaller commercial vehicles will also get electrified, and which will help us to transport lubricants with these means of transport.
So remember when you were in school more than 30 years ago, and you were convinced that this is a good area to spend your professional life. What do you tell
Yep.
a person applying for a job? How do you convince him to join your organization and work in lubricants?
The great question. I think this industry gives you an opportunity to go into everything which is manufactured. So a lubrication, from a pin manufacturing to aircraft manufacturing, is all manufactured in factories. And a lubrication engineer has an opportunity to add value to from the pin to an aircraft manufacturing. So gives you scope of the width of the industry, what you are able to visit and see yourself. Number one. Number two, I think in lubricants is going to remain for a little while, even though the industry from automotive perspective, it's getting electrified, and you're seeing more EV cars on the road. But from a industrial, the EV cars also going to get manufactured somewhere, and that's still going to be in a factory. And so, yes, there may be less parts being manufactured compared to an IC engine, uh, com- uh, with uh, with respect to a EV versus an IC, but they still need to get manufactured. So, industrial manufacturing is going to remain for a little longer time, unless probably they the 3D printing takes over in manufacturing in every aspect. I know 3D printing is a different manufacturing, and I don't think so that is caught on as much as we talked about in the industry. It's being still used for very niche application areas, and it is still very small. So you have an opportunity to, one, work in an industry which is going to be sustainable manufacturing to the future requirements of the consumer. Two, you will be able to get into a plant from a pin manufacturing to aircraft manufacturing. So uh, lubricants play an important role, and I believe um, tribology, if you are interested in tribology, and this is a place to see it yourself, from the laboratory to the manufacturing site.
And I can't help but ask you this. What is the future? It says here Petronas Industrial Solutions future focused. What is the future?
So the future is going to get into services. So it's about how do we help our customers from a product focus towards a services focus. It's an output driven rather than input driven. So the future is also going to be about um, reducing your downtime, reducing your maintenance cost, and to achieve that, you will have to look not only at products but also look at how the product gets used. And to do that, you need to start incorporating the services element of the product, and that's going to be the future. And I believe the future is all about incorporating the service element as much as the product element. Today we are highly focused towards the product part of the offer, but in the future, I think services offer will play an important role along with the product offer.
And that is a very interesting concept that I hope one day we can discuss further, Uday. Thank you so much for your time. Any last words to our audience?
Uh, Thank you, Vicky. And FNL is doing a great job in disseminating technology and new trends in the industry. And I'm pleased I was able to interact with you and help our viewers to get insights about how is it that the lubrication industry tries to help our customers to achieve higher productivity, higher availability, and increased longevity of these equipments.
Well, thank you so much.